Now recall when we studied volumes in Calculus 1, we sometimes looked at curves of the form x equals g of y, where y is the independent variable and x is the dependent variable. And geometrically the picture is the same here, it's just a change of labeling of the axes and perhaps a change of perspective if you've already drawn your axes with the y vertical and the x horizontal. So the formula is exactly the same with the x's and y's switched. So the length of our curve is the integral from c to d, if the y values are running from c to d, of the square root of 1 plus the derivative of x with respect to y squared dy. For example, suppose I wanted to find the length of the curve 24xy equals y to the 4 plus 48 from the point 4 over 3, 2 to 11 over 4, 4. Now it makes more sense to solve for x in terms of y in this curve than to try to solve for y in terms of x. So we can get a formula for x in terms of y, and that's just y to the 4 plus 48 over 24y. And this is a function of y, g of y, and our y values here are running from 2 to 4. So we can use our formula here for the arc length, which is the integral from c to d of the square root of 1 plus g prime y squared dy. And g prime y is easy to calculate, we just have to use the power rule, so it's y squared over 8 minus 2 over y squared, and its square is y to the 4 over 64 minus 2 times the product of y squared over 8 and 2 over y squared plus 2 over y squared squared, which is 4 over y to the 4. And notice that middle term again is negative 1/2, so we can apply Pilkington's law again here. So we have our arc length is the integral from 2 to 4 of the square root of 1 plus g prime of y squared. And once again, that middle term of minus 1/2 becomes plus 1/2 when we subtract it from 1, and we get a plus b squared, or y squared over 8 plus 2 over y squared squared under the square root sign. Now, of course, the square root and the square will cancel, and this is a positive number equal to its absolute value. So we're looking at the integral from 2 to 4 of y squared over 8 plus 2 over y squared dy, which is y cubed over 24 minus 2 over y, evaluated between 2 and 4. And our final answer is that the arc length of this function between these 2 points is 17 over 6.